Hello guys, welcome back. Today we are going to understand today Leetcode question, and we are going to understand this very important question because this question has been asked in all the interview like the product based companies like Fang and other product companies, right? So let's understand what is this question. So today questions we have given is 785 of the Leetcode, and it is about graph bipartite. Yeah, so we have to find is a graph is a bipartite or not, right? So first of all, let's understand what is bipartite, right? So it is saying that the graph is a bipartite if the nodes can be partitioned, right, into two independent set A and set B, right, in such that every edge, right, every edge in the every edge in the graph that connects in node connects a node in a set A and a node in a set B, right? So it should be independent, right? So node A that connects to set A and node A that connects into set B, right? So every edge should be connect, right? Like we have let's suppose we have given for example, let's suppose we have given this example. Okay, so what it is saying that we have returned true or false. So this is bipartite or not. So as you can see here, if you try to partition this one, right, this edge, right, this node 0 1 2 and 3, right? So from where you will do the partition, right? So if you'll take 0 1, right, and in one set, just for understanding, another you will take what 3 and 2, right? So it is not independent, right? If you'll take another one, let's suppose 1 and 3 in the set, right, and another you will take what 0 and 2, right? So 1 3 is connecting with what 0, as well as 1 is also connecting with what 2. So this is not independent, right? But when we are coming back to here in this example, right, so there is no is like this was previously we have given this one, right, but here we don't have. Okay, so if you'll do the partitions, so the two sets will be there, as you can see here, 0 2 and 1 3, right? So 0 2 means what, this is 2 and this is 0. So these two are not directly connected, means these are independent, you can say. It is connected indirectly with 3 or 1, you can say, but it is not directly connected. Similarly, if you talk about 1 and 3, it is not directly connected. So that's why we can say we can partitions this 2 1, right, like 0 and 2 and 1 and 3, and then we can say these two are we can do the bipartite of this graph. This graph is a bipartite and we have to return true. So this was the thing we have to do actually in this program. So the question is saying that there is a undirected graph, we have n nodes we have given, and it is number from 0 to n minus 1. So you have given 2D array graph, and where a graph of u is the array of nodes that node u is adjacent to it, right? So it is also saying that for each v in graph u, you can say there is a undirected edge between node u and v, as you can see here, right? And it is also saying that there is no self edge, there is no self edge is here. So u doesn't contains u again, you can say, means self edge is not there like this we don't have, right? And it is also saying there is no parallel edges, does not contain any duplicate value, means we don't have parallel edges like this where there is no duplicate values also there. So if u is in the graph, then u is in the graph, this one. So graph is undirected. Okay, so if there is we cannot say which direction we have, this direction or this direction, right? We don't have the direction, so this is undirected, and graph may not connected, meaning there may not be two nodes u and v, that is there is a path, right? Like this example. So as you can see, directly two nodes we are not connecting here, as these are not connected. So we can say there can be possibility, right? So now you understand these questions and you have gone through the example, right? So you have to return true or false if the graph is partitions or not partitions, right? So these are the constants we have given. You can keep in mind that all values in the graph we have given is unique, and u doesn't contains u, and if graph u contains v, then graph u contains graph v contains u, like that we have given. And to understand that, what you can see, let's suppose if we are going to understand through the coloring by the depth first search, right? If you are using DFS and you will do the coloring, let's suppose you are starting with a color like this, and this is your, just for understanding, this is your red color. Okay, let me change any other color. Okay, and another I'll take like I'll use some graph like this. Okay, like this, and give me one more time. And again you will have some values like this, you have. And I'll take red back, sorry, not red back. Okay, so let's suppose we have now two points. Okay, now what I'll do, I'll connect all these one in so that let's go with the black one. So let's suppose we are going like this, right? We are connecting all this one. This is the color we have here. Color is what? 0. Here we are connected with all the nodes, right? Now it is connected, as you can see. Now this one will go to connect with all this one, just for understanding. It will go to connect all this one like this, we can go, and this will go like this. This will go like this, and this will go like this. Okay, like this means we are connecting each other. Okay, so what will happen? So first of all, why I am doing these coloring things. So if you will connect your DFS, right? If you will connect your if you are doing the coloring, right, of each level of the node, right? So coloring a node, like you can say this is a green one, right, is a part of the first set, right? Else we will take into another set. So if I'll take this list and we'll say this is your red one and this is your green one, right? So if we'll take like this red and green, right, what will happen? This if a color, let's suppose a green one is a first set, right? So red will be your another set, and if your red is first set, so green will be your another set. Like this you have to make the set and you have to map it. Okay, so and we should be able to greatly color the graph if and only if it is bipartite. So one node being blue implies that or green, you can say, its neighbor are red, right? So all those neighbors are green, right? So we will continue like this, right? Or you can convert it into another color. Okay, so that in that way what we are going to do, so each color we have, color here is we will take like this, another color will take like 1. Okay, another color will take 0 again, and this is 1. So you will have the set of 2 colors and you can implement this one. So better let's go to the color let's go to the program and we'll do the implementation, so you will understand this one. Okay, give me 1 minute. Okay, so we are here at the browser and we are going to implement this one. Okay, so first of all what we should do here, we have given this graph, right? So from the, if we have given graph, we have given, right? So from here what we will find, how many nodes we have. So from the node we will get what graph dot will do, and we can find the length function. So from the length we will get our number of nodes, right? Now what we should do, we can take color of array like this, and we'll say this is nothing but how many nodes we have. So we will mark this node as we will take a array of n nodes we are going to fill here. So how we'll do that? Initially we'll take arrays dot fill is a method, and here we can take what color, and we'll take 1 minus 1, and we will fill this color with -1 value. Okay, now for each color we have the array, right? So we will start from what, the first node, and we'll say this is nothing but our 0, and then we'll I will go to where, you can say less than n, and I plus plus, like this will go. Okay, now what we should do here, so first of all we'll check each index of the color, right? So color at I, right, if it is starting point is what, nothing but our -1, initial value is -1, means we have not did any color, right? Means what we have to do, we have to take one stack, let me internal static, we can say I'll take a stack and will store here nothing but our you can say we have to store all the nodes, so I'll take integer, right? And this is nothing but our Let's suppose this is a stack we'll take, and here what we'll do, new stack, and like this we'll do. Okay, now on the stack we have to do the push. So I will do push, and we'll say we have to put what, I is nothing but it's node, right? So we'll add the node here, right? So each current node we have to if we will find -1, the value means this initial value we have, so we have to say this we are going to push into the stack, and now we have to change the color, right? So color at I is now now this is not -1, but I'm going to put 0, right? We are going to put the 0 value. Okay, so once we fill this value, right, what we have to do here, just we should do we'll check now stack, and we'll go move to all other values. To move all other values, what we have to do, we will, this node is connected with what, right, that we will to move, right, it's neighbor nodes. To find the neighbor nodes, we will check if stack is not is empty, or yeah, is empty, not is there is a method, I think empty. So if this is not empty, it means we have to find the current node. So from the current node we'll get what, our current node will get, and this we can get from what, stack dot pop. So we will remove the stack pop, and then for all its neighbor, what we will do, we'll take int nei, and this is our neighbor node, right? So neighbor nodes we will get each time. How we'll get this? So we can get from what, we have already graph we have, from we'll we can pass the node like this. So if you'll pass this node, as you can see here, graph we have, if you'll pass this graph, right, so graph at node, we should pass, I think, graph at node. This is like this we can do, yeah, because this array. So first of all we have the graph, so graph at node, yeah, at graph of node, right, this current node will pass here. So at the, from the current node we'll get all your you can say neighbors. Once we will have our neighbor nodes, right, what we have to do, we will check our you can say its color. Again you should check this color that we have marked here, right? You can check like this, but color dot I is nothing but what, we have to check neighbor. Now we will check the neighbor, right? So if neighbor is we have already checked the parent, and its neighbor have -1, then what we will do, we'll do stack dot push, and we have to update this one. So we'll do here like this. Okay, so this part is done, but in the here we will push our neighbor node, right? So this part is done. Okay, so once our color of a neighbor node is -1, means we have to push into the stack, and then color of the neighbor node we have to say not equal to 0, but it's we have to check alternate value, right? It should not be 0, but we will take a shift, right? Alternate value, right? You can say we can take a shift value. Let's suppose I'm trying to say we have the current node, right? So from the current node, right, from the current node we can take yeah, we can do like this. We'll take a shift, one shift, right, and we'll have our value here on the current one. Okay, or either you can put any other value. Okay, now what we should do here, will in the else if we will make a condition, and we'll check if the color at the neighbor node, right, if the color at the this neighbor node, if it is equal to, if it is equal to what, this color of I, just for understanding, if it is coming, means parent node. So here in the sense parent node is nothing but what, node, right? So if neighbor node and its parent node both are same, that is not possible actually, but if it is possible, right, it at that time we'll say return false. So this case will only come if it's not bipartite. Okay, otherwise in this case we will have our bipartite, right? It's fine, leave it. Now once it is done, right, so before closing the method we should return here our true. That's all. Let me zoom out. Let me explain again. So what we are trying to do here, actually, we have our graph, then we have our we will find our node and will take number of nodes and will initialize with all the nodes with as a -1 as a color, and then we'll move. Okay, give me 1 second. So let's understand here what I'm trying to say here. So previously, as you have understand that what we will do, first of all, let's suppose we have our node, right? So this node is nothing but our start. Let's suppose this is our start node, right? So from here, what will happen? We will go to all its children, right? So this is your parent node, just for understanding, right? We will go to here. Okay, now from here what we are trying to do, we are going to all its children. Okay, so if there is multiple children are there, right, we'll go to all its children. Similarly, we'll go to all its children. Similarly, if we have some nodes are matching here, right, so this will go to all its sub children, like this we will go. So as you can see, we have started with this as a color, right? Let's suppose this is nothing but our green. Okay, we have started with the green, nothing but red. Our gear going here. So next time this is your red, right? So this next time what all the colors will come on this layer, right, is nothing but what, this is your another color, right? So that's why what we are doing here, first of all we will initialize with the -1. Let's suppose all have the -1, all here is -1, here -1, everywhere is all -1 have, right, the color. So initially what we will check, we'll go to all the nodes, we'll to traverse all the node, we have to make this for loop, right? So after making this for loop, we'll check if color of this is -1, means we are going to start with here. So we will find our -1 as a value here. At that time we'll take a stack and we'll push that this node, this current node, and we'll mark this color as a red. Let's suppose 0 represent for red. Okay, or in this case this is a green, right? So you can mark as a green or any other color. So let's suppose we are going to mark as a green. Okay, now what will happen, we'll move to the while loop and we'll say if we have already pushed the first 0 node here. So if this is on the stack, so if it is not empty, we'll get a pop and we'll return this one and we'll say from the graph this current node will get, right, the root node will get, from the root node will get all its neighbors. So these all nodes will come and one by one will check its color. So we'll check one color, if this is -1, means we have already some -1, every node have -1, right? So in -1, then we'll push onto the stack. So each time it will go to the stack, and then we are pushing here, and in the alt, if there is a color, then we will, the current color we have, so current color whatever we have in the parent, right, here just opposite will take. So if this is green one, all these layer will come as a red one. Okay, so alternate color you will do. To do that, we will mark like this, and then if finally we'll check if colors are not equal, right? So never color and this color, if it is not equal, so in this case what will happen, and we'll say this is not matching, right? And we'll say this is a false, this is not bipartite, right? So we will return. And if this case is not going to match, it is not equal, it means what, we will return our true. Okay, so that's we have here. Let's submit the code now. We are getting where integer stack equal to new, oh sorry, to new we have put it here. Let me submit again. The else condition here, if node at this is this, we will get this for this, and if this, then we'll take if else. Cannot find the symbol node. This is nothing about our current node. Let me submit this one. Current node or node, whatever you will say. Submit this. Means from the root node, if it is not equal, then we will say this is not good. Okay, means this is not bipartite. So thank you guys, thank you for watching this video. But if we'll talk about you can say time complexity, right? So give me 1 second. So in the time complexity, as you can see here, right, how many nodes we have? N nodes we have, right? N nodes we have, and for all the node it is connected with how many edges? N minus 1 edges, right? So n minus 1 edges is nothing but our n edges only, right? So n edges is connected with e edges, right? So we will traverse for all node and its edge, right? So we can say that we'll take time complexity O of n, right? This is your time complexity, because this is the normal thing that we can use into the graph, right? So where n is the number of nodes and e is the number of edges, right? And we have explored each node. Once we will transform it from the different colors, one color to another color, right? So we'll doing this one, as you can see here. Okay, we are transforming, we are traversing all its edges in this process to move into the color, as you can see. So first initially we have put one color here, and then we are converting this color into another color, as you can see here. We are doing another color at this line. Okay, that's why we are getting this one. If we'll talk about the space complexity, right? So only we are talking about node, right? As you can see here, only we are talking about node, right? And we are storing into what? In the stack, right? So in that case, what will happen? We'll take O of n, because we are taking array here, not a stack, because this is the auxiliary space. It will not take time. It will not take a space, but we are taking what is to store this array, right? Color that we are taking, right? So that will come O of n. So thank you guys, thank you for watching this video. Please hit subscribe this channel, so you will get more videos like. For any suggestion, please ping me in the comment box. If you need any help, please ping me in the comment box. We are also providing I've also started 2 batches of data structure and algorithm. If you want to get enrolled in that, my personal mentorship, please ping me in the comment box. Okay, thank you guys, thank you for watching this video.